Welcome. Today, we delve into one of the most fascinating topics in science, the code of the universe. Is mathematics merely a tool created by humans, or does it exist independently of us? Or perhaps mathematics is the foundation of reality, with its principles governing the entire cosmos. Let's immerse ourselves in the mysteries hidden within the universe and discover the significance of mathematics in our understanding of the world. Could it be that mathematics is the code of the universe, embedded in its very foundations? Or do we, humans, find meaning within it, using mathematics as a tool? Mathematics as a discovery, not an invention. Have you ever wondered if mathematics is our invention, or does it exist independently of us? This question has puzzled many scientists and philosophers. One theory suggests that mathematics is not an invention, but a discovery, as if we were uncovering something that is already there, waiting for us. Thesis: mathematics exists independently of humans. Many mathematicians, including Roger Penrose, argue that mathematics exists independently of us. It is not a creation of the human mind, but something we discover, like archaeologists uncover ancient artifacts. Think of the number 3. Would it exist without humans? Many believe that the number 3 is not a human creation. It exists independently of us, just like the Pythagorean theorem or the number pi. Mathematics as a process of discovery. Penrose compares mathematics to archaeology. Imagine digging in the ground, trying to uncover something that is already there, but unseen. Mathematical structures are like fossils, waiting to be found and understood. The fact that we discover them does not mean we created them. We may be unaware of their existence, but that does not change the fact that they are there. Examples of mathematical discoveries. Ideas such as complex numbers, non-Euclidean geometry or fractals were not arbitrarily invented. They were discovered because they described a reality that we could only grasp through mathematics. Moreover, many mathematical theories are discovered long before they find practical applications in science. Thus, mathematics is not only a tool, but also an independent language that describes our world. Similar to the golden ratio, phi, which can be found in the proportions of a snail shell or galaxy structures, mathematics often manifests in harmonious and beautiful forms. The role of mathematics in science and technology. Mathematics is the foundation of science and technology. Without it, we would not have computers, GPS, or the internet. All these technologies rely on mathematical principles. Furthermore, mathematics helps us understand the fundamental laws of nature, from the motion of planets to the quantum microcosm. The mathematical foundation of reality. Mathematics is not just a tool for counting and measuring. It is something much deeper, a fundamental language used by the universe. In this section, we delve into the theory that mathematics not only describes, but also creates our reality. Are the laws of physics merely mathematical recipes? Let's discover this together. Thesis: mathematics is the language of the universe. Many scientists and philosophers, including Roger Penrose, believe that mathematics has a fundamental nature in the structure of the universe. It is not merely a set of tools for describing phenomena, but something at the very heart of reality. When we look at the laws of physics, such as Einstein's equations, we find that they are mathematically encoded. But why is this? Does mathematics govern the universe? Or is the universe so ordered that mathematics is the only way to describe it? Mathematical beauty and universality. Mathematics is often described as beautiful and elegant. But what does that really mean? In the world of science, mathematical beauty often relates to simplicity, symmetry, and universality. An example is the famous equation E equals mc squared, which simply expresses the relationship between mass and energy. This equation, though simple, describes a fundamental truth about the nature of the universe. Similarly, other laws of physics often take the form of elegant mathematical equations. String theory, which suggests that at the most basic level the universe is made of vibrating strings, also uses complex mathematical structures to describe reality. Mathematics as the structure of the universe. Mathematics is not just a tool for describing phenomena, it is also the structure upon which the entire reality is built. In a sense, one could say that the universe is mathematical. Physics and mathematics are inseparable. We cannot discuss physical phenomena without using mathematical concepts. Is this a coincidence? Or is the universe constructed on mathematical principles? Examples of mathematical principles in nature. We see examples of mathematical principles everywhere, from the symmetry of flowers to the golden ratio in art and nature, to fractals in the shapes of mountains or coastlines. These patterns are not only beautiful, but also functional. It seems that mathematics not only describes, but also determines how the universe is constructed. Fractal structures can be compared to a mathematical language that writes nature, allowing for infinite complexity and beauty. Different ways of perceiving mathematics. Have you ever wondered how different people can perceive mathematics in completely different ways? Some see it as abstract patterns and equations, others as visual images. How do you see it? In this section, we explore the diversity of mathematical thinking and how it influences our understanding of the world. Mathematics is one of those areas where diversity in thinking is not only possible, but essential. Some people, like Michael Atiyah, can think both visually and abstractly. Others, like many prominent mathematicians, may prefer a more algebraic, abstract way of thinking. Each of these approaches has its unique advantages and challenges. For some people, mathematics is primarily visual. Imagine geometry. Triangles, circles, cones. All of these can be seen and understood visually. This way of thinking can be very helpful in understanding complex structures and spaces. For example, imagining four-dimensional space-time in relativity theory may be easier for some through visualization. However, not everyone thinks this way. For many, visualization is difficult, sometimes even impossible. On the other hand, there are people who are more comfortable with abstract concepts. For them, mathematics is a game of symbols, patterns, and equations. Algebra, number theory, or mathematical analysis can be like music, sequences of symbols that form harmonious wholes. This way of thinking may be more suitable for solving problems that do not have an obvious visual representation, such as problems in number theory or topology. Both approaches have their strengths. Visual thinking can be extremely intuitive and help understand the spatial and geometric aspects of mathematics. Abstract thinking, on the other hand, allows for a more precise and formal approach to problems. Each of these ways has its challenges. Visual thinkers may struggle with abstract concepts, while those who prefer abstraction may not always see the intuitive visual aspects of problems. A fascinating example is Albert Einstein, who was more of a visual thinker. Although he was not a mathematician in the traditional sense, his intuition and ability to visualize complex spatial structures were crucial in creating the theory of relativity. On the other hand, many mathematicians like David Hilbert specialized in more abstract aspects of mathematics that did not have a direct reflection in physical reality. The relationship between mathematics and physics. When we look at the universe, it seems that everything is ordered according to certain principles. But what lies at the heart of these principles? Is it possible that the universe operates according to a mathematical plan? In this section, we explore how mathematics and physics are intertwined, and how mathematics helps us understand the nature of reality. Many scientists claim that physics and mathematics are inextricably linked. Although physics as a science studies the material world and its phenomena, mathematics provides the tools that allow these phenomena to be described and understood. It is through mathematical models that we can predict the movements of planets, understand the properties of elementary particles, or describe the curvature of space-time. Mathematics is often called the language of physics. Without it, it would be difficult to express complex physical theories. For example, Maxwell's equations describe electromagnetism, and Schrödinger's equation is fundamental to quantum mechanics. Thanks to mathematical formulas, we can precisely state the laws of nature. This is especially important because it allows for the creation of models that can be experimentally tested. One of the most famous examples is Einstein's general theory of relativity. This theory describes gravity not as a force, but as the curvature of space-time by mass and energy. Without mathematics, which enables the precise description of this curved geometry, we could not understand why, for example, light bends near large masses like stars. Another example is quantum mechanics, which operates on a subatomic level. In this field, classical physics is insufficient because the behavior of particles cannot be described in an intuitive way. Instead, we use probability theory, wave functions, and other advanced mathematical concepts that allow for highly accurate predictions of experimental results. Is mathematics merely a tool, or does it exist independently of the physical world? This question has puzzled many philosophers. Some, like Roger Penrose, suggest that mathematics exists in its own world, independent of physical reality. Others argue that mathematics is merely a construct of our minds, used to describe the world. Either way, mathematics and physics are inextricably linked, forming the foundation of our understanding of the universe. Einstein, the theory of relativity, and the role of mathematics. Albert Einstein is one of the most iconic figures in science, best known for his theory of relativity. But did you know that despite his genius, he had his challenges with mathematics? In this section, we will explore how Einstein used mathematics to revolutionize our understanding of the universe and what challenges he faced along the way. Einstein was not only a great physicist, but also a visionary who could combine his intuitive understanding of physics with mathematical tools. Although he admitted that mathematics was not his strongest suit, it was through mathematics that he could describe phenomena that were previously beyond the reach of science. His ability to imagine complex concepts, such as curved space-time, was crucial in his work. In the special theory of relativity, Einstein described how the speed of light is constant for all observers, regardless of their motion. This discovery changed our understanding of time and space, showing that they are closely connected. To describe this, Einstein used mathematics, specifically the Lorentz equations, which were already known. However, he understood how these equations describe physical reality. In the general theory of relativity, Einstein went even further, describing gravity not as a force, but as the curvature of space-time by mass. The key mathematical tools he used were differential mathematics and Riemannian geometry, which allowed him to describe curved spaces. Initially, Einstein was not a fan of these abstract mathematical concepts, but he quickly realized they were essential for a complete understanding of gravity. Although Einstein used mathematics in his work, it was not always easy for him. His difficulties with mathematical concepts were well known. For example, he often relied on the help of mathematician Marcel Grossmann, who helped him understand the intricacies of differential geometry. This shows that even the greatest geniuses can struggle with certain aspects of science. Nonetheless, Einstein was able to combine his intuitive understanding of physics with mathematical tools, leading to some of the greatest discoveries of the 20th century. Einstein taught us that mathematics is not just a language we use to describe physical phenomena, but also a tool that can lead to new discoveries. His theories changed our perception of time, space, and gravity, and mathematics was a key element of this process. It is through mathematical equations that we can now predict phenomena such as black holes or gravitational waves, which have been confirmed by modern experiments. In conclusion, mathematics seems to be the key to understanding the universe. It can be seen as the language in which the universe speaks to us, offering deep and elegant descriptions of the nature of reality. Its independence from the human mind and universality in describing physical phenomena underline its fundamental role. Despite his challenges with mathematics, Albert Einstein managed to harness its potential for groundbreaking discoveries that changed our understanding of time, space, and gravity. However, certain questions continue to intrigue scientists and philosophers. Is mathematics a discovery or an invention? Does it exist independently of us and we merely discover it? Or is it just a tool of our mind to describe the world? Could the universe exist without mathematical principles, or are they a fundamental element of reality? These are questions we still do not have definitive answers to, but exploring them leads us to an ever deeper understanding of the universe's mysteries.